بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. We have studied math first, second. We see the content of this course. We'll first speak about matrix, linear programming, vectors, and straight line and trigonometry. Here I am Mr. Muhammad Ali. Okay. Let's see the material. We will study with the students and workbook. We will take some software to do this courses like MATLAB and Excel. Okay. Chapter 1 talk about organizing data in a matrix and adding and subtracting matrix, linear programming and optimization, determinant and multiplicative inverse of a matrix. What is the importance of a study matrix? That is a report. We take it as a report to know what is the importance of the matrix. Okay. Let's talk about matrices. The definition of the matrices: a matrix is a collection of a number arranged into a fixed number of rows and columns. Matrix like this contains rows. This is a first row, second row, third row, first column, second column, and third column. You say now that is a first column, first row. That is a first row, second row, third row, and then first column, second column, and third column. Okay. Okay, after that, matrix contains elements. Let's row 1, row 2, row 3, until row m, column 1, column 2, column 3, and column 4. This is the element A11, first element, second element, third element, and so on. A matrix of m rows and n columns is called a matrix with a dimension m10. To know how to determine the dimension, like this matrix, first example, you see now, first row, second row, then this is 2 times. First column, second column, third column. Sorry. Then this matrix is order and the dimension the same 2 times 3. First 2 times 3. Then 3 times 3, 3 rows and 3 columns. 2 times 1, 2 rows, and first one, only 1 column. Here, 1 row and 2 columns. 1 times 2. This 1, 2, 3 rows and 2 columns. Here, 2 rows and 2 columns. 2 times 2. Yes. Here, 1, 2, 3, 1, 2, 3. Okay? Here, 1 rows and 2 columns. Here, 2 rows and 1 column. And then 2 times 1. You know why? 2 rows and only 1 column. Okay. Here, 1 element only. 1 times 1. Okay. Organizing data in matrix. That's an example. If A and B and C are 3 cities, the distance in kilometers between A and 7 is shown in the table of. Write a matrix represents this data. Okay, we do now matrix represents this data. Let's say that is the name is A. Okay, A equals matrix 0, 75, 80, 75, 0, 56, 80, 56, and 8. This is a matrix of ordered what? Ordered 3 times 3. This is the order of matrix. Okay. Let X be the required matrix A find the following. What does it mean by X to 3? In this matrix is called X. 0 and 75 and 80, 75, 0, 56, 80, 56, 0, order in the 3. What does it mean by X to 3? Where is X to 3? Second row, third column. Second row and third column. Where is the element then? That is the element we'll talk about. What does it mean? He said that the distance in kilometers between A to Z, 56 and B. You know that the distance between B and C. That is distance between city B and C. Okay. And so, use the matrix P 1, 3, 5, 5 to 7 to answer each of the following. What is the order of the matrix P? There are 1, 2, 3 rows and 2 columns. In this order, the order will be 3 times 2, 3 rows and 2 columns. What is the value of P12? P12 means 1 and 2, then the element will be 5. Let's see 5. So P12 equals 5. P21 1, the element will be there, 2. Okay, that's good. If I have any matrix with order Bij, R equal 1 and 2, G equal 1, 2, 3, number of columns, and number of rows and number of columns will be that. Okay? That's right. Some special methods. First, square matrix. What does it mean by square matrix? The matrix in which the number of its rows equals the number of its columns. Like as an example, negative 3, 4, 2, negative 1. This matrix will be called square matrix. So the number of rows equals the number of columns. If I say 3, 4, 5, 2, 3, 6, 8, 5, 2, the matrix 3 times 3. Square matrix. Because number of rows equal number of columns. Okay. Row matrix is a matrix containing one row with any number of columns. Only one row. 2, 4, 5. Mean 1 times 3. Only one row. Only one row. Okay. It's called row matrix. Column matrix, a matrix containing one column. Now, column matrix, one column. As you see, 2, 5, 6. It's 1, sorry. That is 3 multiplied by 1. Only one column. After that, zero matrix. Zero matrix is a matrix in which all of its elements are zeros. All of its elements are zeros. Like this. Maybe that This order to square 0 matrix and then by 4. Diagonal matrix means square matrix which all elements are 0 except the diagonals of at least one of them is not equal to 0, like this. Okay? The diagonals are not equal to zeros and all elements after that equal to zeros. Okay. The unit matrix, a diagonal matrix in which each element on the mean diagonals has a number 1. Diagonals now is equal to 1. This is called diagonal matrix. Diagonal matrix. A unit matrix is equal to say the name is unit matrix. Now try to solve this example. First, write the type and order of each of the following matrices. Number 1, number A is 2 times 2. Is 2 times 2. Why? Because we only have 2 rows and 2 columns. And what's the type? Yes, square matrix. Square matrix. Okay. Then number B, 1 times 1, 2, 3, 4, 1 times 4, and this is called row matrix. Row matrix. Okay. Number C, column matrix. Yes, column matrix. And order 1, 3 times 1. That's it. And so quality of two matrices. When I say the two matrices are equal, you say that if and only if they have the same order and the same elements of the matrix. To achieve that, you must be matrix like this. Order 2 and 2 will be equal to the same. 2 5 x 6. To say that two matrices will be equal, we must then x must be equal to must be x equal 4 to achieve equality. Okay? As you say, so do matrix first. Now order 1, 2 and 2 times 2, but this 2 times 3. Now they are different in order. They are different in order. Second example, same order, and we will be equal when x equal negative 3 and y equal 5. Okay? Number C, two matrix 2 times 2 times 2, but there are different elements. Say that here is negative 1 or here is 1. Then they don't equal. They cannot be equal because the corresponding elements are not equal. Last one, 3 times 3 times 3, and each element are equal. Then the two matrices are equal because they have the same order and the corresponding elements are equal. Okay. Use the equal matrix to solve the equations. If 2x plus 5, 3, 4, 10, y plus 12 equal 25, 3, 4, y plus 18, find the value of x and y. Okay? We'll take this equal to that. 2x 8, 2x plus 5 equal 5, 2x equal 25 minus 5, then 2x equal 20, x equal 10. That's the first, and we will take another one, 3y plus 12 and y plus 18. Solve this equation. d1 plus 12 equals y plus 18. Then d1 minus 1 equals 18 minus 12. 2y equals 6. Y equals 3. Okay. Another definition of matrices is symmetric and skew symmetric. What's the difference between symmetric and skew symmetric? E is a matrix, then it's called a symmetric if and only if A equals A transpose. What does it mean by A transpose? Let's see. We have matrix P equals, I want to get P transpose. Take first row and write it in the first column by 0, 1, negative 1. Then convert second row to second column. This negative 1, 0, 3. And the last one is the last column 1, negative 3, 0. This is called P transpose. P transpose. Okay? Now we ask if it's symmetric or skew symmetric. What's the difference between symmetric and skew symmetric? I say that symmetric if and only if A equals A transpose. And both skew symmetric if and only A equals negative A transpose. Okay. We will do the same thing. P transpose equals 0, 1, negative 1, negative 1, 0, 3, 1, negative 3, 0. But it's not equal to B. 1, 0, here, 0 has to be, but it's negative 1, it is 1. Okay. I will multiply P transpose by negative 1. Negative 1 times 0, 0, negative 1 times negative 1 is 1, negative 1, negative 1, 0, 3, 1, 3, 0. You say now it is equal to P. You say now it is equal to P. Then it will be called a skew symmetric matrix. Then that row is a skew symmetric matrix. Okay, that's right. We speak about the transpose. Okay, I think example about the transpose matrix. We see that the transpose will be equal to 1, 2, negative 1, 3, negative 1, 5. The transpose equal 1, negative 2, 6. C transpose equal negative 3, 4, 2, negative 1. This is exercise, please try to do it. Addition and subtraction of matrix. Okay, that is another lesson. Sometimes we need to add or subtract the matrix in order to get a new data. To find the matrix addition and the corresponding element, if A and B are two matrices of order M and N, then A plus B is also a matrix of order M. You say now, this is very important. If two matrices have the same order. That is the condition. Okay, then we can say that A and B is also a matrix of order. Will give the same order. Let's see. To add matrix, we add the corresponding element. They must have the same dimension. If matrix A order 2 times 2 and matrix B order 2 times 2. Okay? Then A plus B will be negative 5. We will add it with the corresponding element 6 and 0 is negative 3 and 4 will be 2 and 1 plus 3. Okay? We will get this answer. With the same order 2 times 2, 2 times 2, the answer will be 2 times 2 same order. Another example, add matrix with 0 matrix, then the result will be the same matrix. 2, negative 1, 3, 1, negative 1. So the 0 matrix is added to another matrix of the same dimension. That same matrix is obtained. Okay. Try to solve, find each of the following if possible. Say now, we say if possible. Okay, let's see. A plus B means negative 4, negative 1, negative 3, negative 7, order. Sorry. Order 2 times 2 and B with the same order. Now we can add it. Then the result will be negative 4 plus 2 will be negative 2, negative 1 plus negative 7 will be negative 8, negative 3 plus 8 will be 5, negative 7 plus negative 12 will be negative 8 with the same dimension. But I can't make this. Why? Because it's not possible. Because the iron has same dimension. Thank you very much, and we see you another time.